We from the team of Step Up Bengal welcome all of you in the next video lecture of Lagrangian mechanics. এই ভিডিও শুরুতেই সকল বাঙালিদের হ্যাপি বেঙ্গলি নিউ ইয়ার জানাই। সবার বছরটা ভালো কাটুক। We hope that this Bengali New Year will bring all of you the things you cherished for a long time. আজকের এই ভিডিওতে আমরা আলোচনা করব CSIR নেট ম্যাথ নভেম্বর 2020 4.75 মার্কসের কোশ্চেন। This particular question is based on Euler-Lagrange equation. This is famous equation. I hope all of you are very familiar with this equation, Euler-Lagrange equation. They have asked in this question about different forms of Euler-Lagrange equation. So far we have discussed how Lagrangian function can be formed by t minus v configuration. Here in this question this v is replaced by capital U. That means potential energy in this particular question is denoted by P. So we first of all would like to just describe this question in terms of U. So we just change our V notation into U notation and try to realize what is given in the question. Actually this question can be marked as a twofold problem. Why? In the first two options there is a simple thing asked, Lagrange equation. That means Euler-Lagrange equation. We all know that equation is formed on the basis of L. That means Lagrangian function, and that is obviously ddt of del L. We have formed L already in the previous video lectures. Those are new to this channel, please visit our channel and playlist of classical mechanics so that you can easily be familiar with L, and that is the difference of kinetic energy and potential energy. So ddt of del L by del Qi dot minus del L by del Qi equal to 0. Here Qi generalized coordinate. For sake of simplicity, we often used in the previous lectures r theta phi format or r theta z format. So here the coordinates are 3. So I runs from 1, 2 and up to 3. So this is famous Euler-Lagrange equation. In the first two options they have asked about it. Let us see. In the first option they have described ddt of del L by del Qi dot equal to del L by del Q. In the second option they have given ddt of del L by del Q equal to del L by del Qi dot. Now see here. Now if we just take this term to the right of the equation, then here comes the positive equal to sign and this will be eliminated. So when we have differentiation, that means time differentiation of the quantity within the bracket, that means when we have ddt format in the bracket we should have del Qi dot format. So within bracket where there is ddt type form there should be and must be dot formation. That means velocity differential. We have discussed in the previous video lecture that this is nothing but velocity differential of Lagrangian partial. So when we take the time derivative of velocity differential, then as in the outside we see ddt, so should be inside we should see dot. Here this dot is essential, rather we should mark with different color. This one, this quantity is essential quantity. Whenever, just remember this trick, whenever there is ddt type, in the bracket we should have dot. But in the first option, in the second option, they have given ddt but del qi, del l by del q, not the one that is dot with dot. And also one thing is very much important in this question, that kinetic energy and potential energy is given in a single coordinate type. That means Lagrangian here is a function of q comma q dot. So only one coordinate is there. Say this is r, so Lagrange, so that Lagrangian is r comma r dot type. So there is no need to use summation or etc. here, or we should not use del qi something. So this particular result actually simplifies in our given case, which CSIR has asked to solve del L by del Q, not Qi, because only one coordinate is there, say R or theta or Z or X, maybe whatever it may be, and that is equal to, whenever there is dt we should have dot here, and the other one should be free from dot. That means del L by del Q. In which option it is given? It is given in the first option. That means here time derivative and q dot. So this is the result. So this option is eliminated. Now I have told you that this is a twofold problem. Why this is, we would see in this part. Here another important concept is critically imposed in the question, and for which when the question was set, many of the students were in serious difficulty, because all of the students mostly very much familiar with this equation, Euler-Lagrange equation. So within fraction of second they choose what was the right option between 1 and 2. But it was multiple select question, so more than one options may be correct. And for that they have given in this twofold problem another important concept. We will just briefly discuss this concept, that is called stability of equilibrium. This is important. Stability of equilibrium. Actually, to handle this type of questions, you should have very good idea about UG mechanics. That means Newtonian mechanics. In that mechanics, a particular formation is drawn, that is stability of equilibrium. And in this particular problem, they have used here that concept. So this problem is a twofold problem, where two types, or rather two ideas are asked. One is Euler-Lagrange equation and the other one we would now discuss. This is called stability of equilibrium. For this, we have to draw a very simple figure. Just I was talking about in UG mechanics, we have also a different playlist. If you want to just concentrate on those topics, then please visit our channel and go to UG mechanics math, applied math playlist. There you can easily have this type of discussions. And for any other discussions, please comment, so that we can provide the need you want. Now take a look at one thing. This is, say this is a curve, and we want a particular mass, say small ball here of m mass. So this will in fact stand here, stand still, এখানে স্থির দাঁড়িয়ে থাকবে এটা, that will not move in general. And we have placed similar type of mass m here also, this m. Now these two positions are extremely critical to realize stability of equilibrium, because though these two masses are now standing still, but if you apply just a simple force this way or this way, then that mass will move away. This mass will move away. এই মাসটা এখান থেকে সরে যাবে এবং এটা আর কখনোই এখানে ফিরবে না। If we apply a particular force, say F1, in this direction, this mass will just move away and will not return to this stable position. These two positions were stable because the masses were standing still here, this stable position. So the stability here discussed in this first case, this is the first case, this is the second, this is stable. Can we call it stable? Answer is no. So this type of equilibrium is called unstable equilibrium. Whereas in this position, take a look at the fact that if we apply just a force F2, say in this direction or in this direction, and then just let it go in its own way, মানে মাছটাকে নিজের ইচ্ছা মতো যদি যেতে দিই, then it will again come back to this position. The beauty is that if we apply a particular force F2 on it and just withdraw the force, then the mass will again come back to its original position. That means the position of stability. Such type of position is called stable equilibrium. So it is now clear to us which one is stable and which one is unstable. But for this, in Newtonian mechanics, there is a nice idea. What is that idea? See one thing. This particular setup is drawn in gravitational field. গ্র্যাভিটেশনাল ফিল্ডের মধ্যে এই সেটআপটা আমরা করে নিলাম। এখন now if this is mass m, then there is a particular height, say this is a fixed axis from where heights of the masses are calculated. So this is a particular height, say this height is h1 and the second mass is at height h2. Then what will be the potential energy of mass m due to mg? We have already discussed mg h1 for mass m. Say this is mass m1 and this is m2 for mass m1 and mg h2 for mass m2. Now see one thing, that from calculus these positions here are different from the point of view of differential calculus, because the positions here or here, that means position A, B, C, etc. are position of maximum, and whereas the position E, F, G are position of minimum. That means when the particle is at maximum height, that means max potential energy, say U max, when U is max, then the equilibrium is unstable. When U is minimum, on the other hand, this is stable. That means when U is minimum, the potential energy or the position of the particle will be potential energy will be minimum, and the particle, or rather equilibrium position of the particle, will be stable. Now see one thing, these two masses are standing still, so at equilibrium point their velocities, their velocities should be 0. This is important. And as we know, for maximum or minimum in differential calculus, the derivative, that means, say we are taking, say these heights are measured as z. So z is h1 in this case and h2 in this case. So the derivative of potential energy with respect to that height should be 0 for maximum minimum. This is the first condition. And when d2u by dz2, this particular derivative exists and less than 0, we know that is a position of maximum. And when d2u by dz2 greater than 0, we know that position is a position of minimum. So here for equilibrium we should have du by dz equal to 0, that means the differential of potential energy should be 0, and also velocity should be 0. Now take a look at the problem, which was given in twofold type. The point q0 comma q0 dot is an equilibrium position of the dynamical system if and only if velocity q0 dot is equal to 0 and del u by del q at q equal to q0 equal to 0. Here q0 dot equal to 0 is given, but this is greater than 0. This greater than 0 will be applied for second derivative to see maximum or minimum position. Here they have not asked about maximum or minimum position. They have asked about equilibrium position. Any equilibrium position, in fact, may be position of stability or position of instability and stability. Position, it may be stable or unstable. These two types are important. So whenever we have stability or instability, the only condition is that the first derivative should be 0. But here in the problem, just we have to make a fine change, that here they have given this z as q, single coordinate. So this is q, this is measured at q, and value of q at this particular point, say this is q equal to q0. So whether it is maximum or minimum, that means q at particular point q and q at q0, the only condition will be velocity should be 0. Velocity should be 0. Here we have seen that velocity should be 0, and the first derivative of potential with respect to that coordinate, that means du by dq at q equal to q0, should not it be equal to 0? It should be and must be equal to 0. Equal to 0 তো এটা হতেই হবে, otherwise the problem solved হবে না. So look at the thing here. Here it is given to be greater than 0, so this is wrong option. Obviously this is correct. So option 1 and 3 for this question is correct. In the next video lecture, I hope all of you have understood this clearly. In the next video lecture, we should discuss rather some more forms of Euler-Lagrange equations and related problems which have been set in CSIR or many other competitive exam like WB set, etc. So until then, goodbye.